In this problem, we're given the graph of a function, and we need to find various information about that. So let's start with the domain of the function. And I'm going to bring in the zoomed in version of the graph. So let's take a look at that. All right, well, we can see enough here, and we can still see some of the instructions. Okay, so I've got the graph of my function. I want to know what the domain is. So I'm looking to see what x values are being used by the function. We can see that, of course, there's an x value at 4, and there's an x value at 0, and, there's a lot of x values. Now, what is the set of all of those x values all together? So I'm going to work from left to right, and I'm looking to see what values we have. So the graph, you can see, is going off the edge here. We assume that it's going to continue going forever in that direction. Anything that's off the graph, we just say continues to do whatever it's done. If there were some way that it was going to stop or it was going to take a turn, then in order to use that information, we'd have to be able to see the graph. So our domain is starting at -infinity. And I'll use interval notation here. So -infinity, this is the domain. And we keep going, and I'm looking again at x values. I'm not worried about whether the graph is going up or down. I just worry about it's still going through all of these x values. And where does it stop? It actually does stop here. And let's clear that so we can see at what point it stops. So it's stopping at 5.5. And that point is included, so I use a bracket, and that's my domain. All right. Now we want to do the same thing, but for the y values. We're looking for the range. So what are the y values for this graph? Again, from the bottom up. So our graph is coming up from -infinity, and it continues until we get to 4. Doesn't go any higher than 4, but there is a value there at 4, so we include that with a bracket. So now we've got the domain and range of f. Now the domain in particular we're very interested in because we'll be using pieces of the domain to answer some other questions in a little bit. All right. Now we want to find the zeros of f. So that just means where is the graph crossing the x-axis. And we have 2 zeros for this graph. So we have one that's at, is that about 1.5? So x is 1.5, y is 0. Or you can say 1.5, either way, unless it specifies it has to be in ordered pair format. And then our second one is the 5.5, comma 0. So those are the zeros of the graph. They're also sometimes called the roots of the graph. So zeros because if we set the whole function equal to 0, that's what we would get. Okay. All right, next, what is f of -1? All right, so I look for an x value of -1, and I'm just checking to see what the y value is, which is +1. I'll just squeeze that in there. There you go. And now we want the intervals on which f is increasing. So this is going to be a portion of the domain. Again, we're talking about for what x values is the graph increasing. So I'm going to trace along the graph. It's increasing, it's increasing, it's increasing. So all the way from -infinity increasing, 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 and it stops here. Now, here's the tricky part. Let's do this. What we're looking at is for what x values is the function increasing. The increasing is determined by the y values. So don't give the y values as an answer because we're just looking for, as you know, where are the y values going up and as x is increasing, and then we look at what are the x values where that happened. So whenever it's a where question, or what are the intervals on which f is doing something, then you are going to give an answer with x values in it. And so it goes from negative infinity all the way up to x equals 2. And we're going to put a parenthesis on that. We never use brackets on increasing, decreasing, or constant because we can't include the point where it's changing from increasing to decreasing, because then should it be included for increasing or should it be included for decreasing? And it can't be both at the same time. So there you go. And then the graph is going to be decreasing the rest of the way. So that starts up just after 2, and it goes until we get to 5.5 because the graph doesn't go forever. And I'm still putting a parenthesis on that. So for increasing, decreasing, we put a parenthesis on it. So right at this point, that's an end point. It is not going to be increasing or decreasing. So we just don't include any of the endpoints when we're looking at increasing or decreasing. All right, so we've got, let's see, we're all the way up to f already. What values do we have where f of x is less than or equal to 0? All right, so what we're looking for is for what values is the graph at or below the x-axis. So that would be here it's equal to 0, here it's equal to 0, and then for this part it's less than 0. So again, we're looking for x values, so the values for which f of x is less than or equal to 0. So that's going to be from negative infinity to negative 2, and it said equal to, so I can use a bracket here because this is not an increasing, decreasing question. This is just saying where is the y value less than or equal to 0. So we've got that interval, union, and then we just have a single point over here, so you would write that like so. Oh, zipped is not 5. It's 5.5. And there you go. Any relative maxima or minima. So we're looking for the very highest point or the very lowest point, but it has to be the lowest point in a neighborhood or the highest point in a neighborhood. So here I have a highest point because if I draw a little circle around that, there is no point within that little circle surrounding that point that is higher than the point I just picked out. So that means we have a max, and we would say at x equals 2, and the max value, max value is 4. And now I look for a minimum. I don't have a relative minimum. I could say, oh, well, that's the lowest point on the graph, but I can't talk about a neighborhood of it. It's just really where the graph is going off the edge of the paper there. That's not anything about the function itself. It's just however they decided to graph the function. So that's not a minimum. And that is my final answer for that. All right. The values of x for which f of x is equal to 4. This is kind of like part G. So now I'm looking for where is the function y value equal to 4. So all I have to do is just look anywhere on this line, and there's one point, and it's at 2, 4. Or we just want the x value, right? So it's just 2. And then the question is f of 4 positive or negative? All right, so one more is f of 4. So f of 4 is right here. And f of 4, that means the y value. So is the y value positive or negative? Well, we're in quadrant 1, so the answer is definitely positive. But it's because of the y value, not because of the x value. And that's how you do that problem.